grade 11s. Today I'm looking at the CAM on page 113 from my workbook. Just check which one that is on your workbook. What they want you to do here is to draw the displacement graph using a horizontal scale of 6mm equals 30 degrees. Indicate the direction of rotation on the CAM profile. Label the displacement graph and indicate the scale used. So what we need to remember is that in a roller follower, the points that we project across to our displacement graph is on the center points. So they've given us all the points here, and we'll obviously have to draw in the pizza slices and fill in the camshaft, hatch the camshaft. I've done the first two steps. I've hatched the camshaft and I've indicated the direction, which is clockwise. If we are going clockwise, remember we need to label anti-clockwise. So I'm now going to put in my pizza slices. I've put in my pizza slices and labeled them. However, we've got one here that is on a 15-degree angle, so we need to just put that in. It's not going to matter too much drawing this line in, because it's going to go to that center point anyway. Remember now, my center point of the roller is where the displacement graph measurements go, so I'm projecting that across there. What is the total length that I need? I need 6mm by 12, so 12 times 6 equals a length of 72mm, so I can mark that off. I'm just going to pick a start point here and then mark off my distance of 72. And what I'll need to do in that distance is mark off my 6mm increments. I'm going to show you two things that you can do here. First of all, I would take my center point to my 30-degree point, transfer the measurement. Center point for 60, center point for 90. Just make sure I label them so I don't mix them up. Now once I've done that, I would need to project the point back to the graph. To correspond with the measurement there. So that's one method of doing it, where we transfer our measurement to our vertical line and then project the measurement back. Now the other thing that you can do is this. I've projected my center line from the center of my camshaft. Now what I'm going to do to find my remaining points, some of the other points here, once again from the center I go to the center of my measurement at 120. Now with that distance I'm bringing it to this line that I've extended here, and I can then mark it off on my 120 line. If I go to my next point at 150, same process. Looks like that was a dwell. Here's my 150. Roughly a dwell period. And there was at 165. So there was a dwell. 180. Slight change. Can work this way because it'll give you the same distance. That was at 180. So that's up to you. So the two different methods, we're either going to transfer your measurement to your vertical line and project it, or you could take the distance from your compass but make sure that you put in that same line running through. I'm going to finish off all the other points. I've plotted all my remaining points over here, and what I see now I actually need to just finish off is labeling my graph here. So the displacement graph in block letter capitals, to neat it up you could put in two guidelines. So put in a height of 3 millimeters here, and there you know where the highest and lowest points are of your printing. Same on this side. Vertical scale. And what you'll see I've done is I've followed where the dot finishes on the bottom of that 5 millimeter increment. I'm going to go over the graph now in dark lines. Now what we should notice is that this should, because it's uniform motion, these points should all be in a straight line. Pretty much. There we go. That looks like a dwell period, so B should be in a straight line. Then there was a rise again. Then it looks like it's falling to our lowest point. And again, just check to see what that looks like. And there is the completed drawing for page 113 in my workbook, where we're drawing the displacement graph of uniform motion for the following CAM.